Welcome to Laws of Indices. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so we're going to begin by looking at writing the following in index form. Now all that means, the word index just means to use powers. And so to work out what index form is, we just need to see how many of the same item we are multiplying together. So p times p times p times p times p. Well, there we have 5 of them, and therefore we have p to the power of 5. Now this little 5, that is a power, but it's also known as an index. One index, if you've got more than one, you have indices. So indices is just the plural of index. We're going to do the same for 5 times 5 times 5 times 5. Well, in this case, we have 4 of them. So 5 is the base, but there is a power or an index of 4. T times t times t. Well, the base is t, because that's the thing that we're repeating. We have 3 of them, so we would call that t cubed. In the next one, we have 32 times 32 times 32 times 32 times 32. Well, in this case, the base is going to be 32. And we want to see how many of those we have. Well, in total, there are 5 of them being multiplied together, so that is 32 to the power of 5. And finally, we have 0.7 times 0.7 times 0.7 times 0.7 times 0.7 times 0.7. That tells me that 0.7 is my base. How many of them are there? Well, there are 6. And so we have 0.7 to the power of 6. So this video is called Laws of Indices, and so we need to start looking at what those laws are, and they are broken into 3 sections. The first one is the multiplication rule, and I'm just going to show you an example. Now this is only for examples purposes. You wouldn't do this if you were actually trying to work out the answer in an exam. This is just to show you where the answers come from. So we begin with, how could we write n squared times n cubed? Well, if we were to write those out in full, n squared would be n times n cubed would be n times n times n. And so if you put those together as n squared times n cubed, well, that would give us n times n squared times n times n times n cubed. We'll put them all together, and on their own, we could just write that as a single power, n to the power of 5. So how could we get straight from this question of n squared times n cubed to this answer of n to the power of 5? Well, if we look at the 2 indices, 2 and 3, well, they add together to give 5. And so that is our rule. If we multiply powers, we add the powers together. The second laws of indices that we're going to look at is when we have division. So again, let's just have a think about this. How could we write n to the power of 8 divided by n cubed? Well, again, let's think about writing that out in full. We've got n times 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 n. That's n to the power of 8. And n cubed is n times n times n. And so if we wrote that out, n to the power of 8 divided by n cubed would look like this. But what we have here is a fraction, and when we have fractions we can cancel out common factors. And so this first n, well, it cancels with this first n. The second n cancels with this n, and this one cancels with this one. What it's left us with is just simply 1 on the bottom. Now if we are dividing by 1, that just means it's exactly the same as what we started with. So all we are actually left with is what is at the top. We are left with n times n times n times n times n. And that is n to the power of 5. So again, how could I have gone straight from the original question to this answer? Well, again, if we look at the powers, n to the power of 8, n to the power of 3, we've ended up with 5. What could I do to get straight from there? Well, I could simply subtract the powers. 8 take away 3 is 5. And so there's our rule. If we divide with powers, we subtract the powers. So let's see if we can put that into action with a few questions. We're not going to write these out in full like we've just done for the examples. We're just going to try and use our laws of indices to get the answers straight out. So in the first question we have y to the power of 5 times y to the power of 2. So this is a multiplication. If we are multiplying with powers, we add the powers together. And so in this case, the base of y will remain the same, but the power is going to be 5 plus 2, it's going to be 7. So y to the power of 7. In question 2, this is a division. When we divide with powers, we subtract the powers. So b as our base is going to remain exactly as it was, but now it's going to be 6 take away 4, which is 2. In question 3, we have multiplication and multiplication. Now, just because this is repeated doesn't change anything. We are still going to add those powers together. So it's still going to be t as our base, but we've got 6 plus 4 plus 2. So we have a total of 12. And in number 4, it's a division. If it's a division, we subtract the powers. So r is still our base. 10 take away 9 is 1. Now this power of 1 is very important because if it's a power of 1, well, it means that there is just one of them. And so actually, if we ever got an answer with a power of 1, we would just call it r. And the other thing to think about there is if you just see a letter on its own, that means you can write it as a power of 1. In number 5, we've got y cubed times y cubed. Again, we've got a multiplication, so we're going to add those powers together. The base is going to remain as y. 3 plus 3 is 6. And so then in question 6, we've got b to the power of 3 divided by b to the power of 4. Once again, we've got a division, which means we need to subtract our powers. Now, the base is still going to be b, but we're going to do 3 take away 4. Now, this one actually comes out as a negative. 3 take away 4 is negative 1. Now, that is absolutely fine. Some indices are negative, and so that's absolutely fine. B to the power of negative 1 is exactly what we would want. And number 7, we've got a multiplication and a division. Now, all we need to remember here is our rules with BidMaths. BidMaths tells us that we just perform multiplication and division in the order that they turn up. And so we're going to do the first part first, the multiplication. So t to the power of 7 times t to the power of 5. That's going to be an addition. So we're going to have t to the power of 12. But then t to the power of 12 is going to be divided by t to the power of 6. And at this stage, remembering that division means subtraction, so 12 take away 6, that's going to give me t to the power of 6. And finally, in 8, we have r squared divided by r squared. So it's a division, so we're going to subtract the powers. And so if I do that, I'm still going to have a base of r, but 2 take away 2 is 0. Now again, a power of 0 seems to be a little bit odd, but it does happen, and it actually gives us an answer of 1. And the reason for that is we've got r squared divided by r squared. We have something divided by itself. If you take anything and divide it by itself, you get 1, and so any value with a power of 0 will be 1. So x to the power of 0, 1. Y to the power of 0 is 1. 1,000 to the power of 0 is 1. No matter what it is, a power of 0 will always equal 1. And so our third and final law of indices comes when we have brackets. And the brackets in particular are a situation where we have a number raised to a power being raised to another power. So in this case, we've got n cubed being raised to the power of 2. And so I just wanted to again have a look at how we would actually set that out. Well, we need to think about what this power at the end actually means. it means that everything inside of the bracket is being squared, multiplied by itself. And so we could write that as n cubed times n cubed being multiplied by itself. And then if we think about our rules of indices, well, this is a multiplication. And so those two powers are being added. And so that becomes n to the power of 6. Once again, how could we get from this original question of n cubed to the power of 2 straight to the answer of n to the power of 6? What would I need to do with those powers? Well, if we have a look, 3 times 2 equals 6. And so that is our rule. If we raise a power to another power, we multiply the powers together. So let's test out that rule. Simplify the following expressions. A to the power of 6 raised to the power of 3. So in this case, it's still going to be a base of A, but we've got 6 and 3, so 6 times 3, well, that's going to be 18. In the second one, we've got f to the power of 4 being raised to the power of negative 2. Now again, a negative power is absolutely fine, and it's still the same process. We still want to multiply those together. So we're going to have f as our base. 4 times negative 2 is negative 8. In question 3, I have r to the power of 3 being raised to the power of 0. Now if I multiply those two powers together, it's still going to be r. What is 3 times 0? Well, anything times 0 is 0, so that is r to the power of 0. But again, just a reminder, because that is a power of 0, we can actually just call that 1. In the second part, we've got, in the brackets this time, 2a squared to the power of 3. Now with these ones, we have to be a little bit careful, because what this is actually saying is we need to think about this in two pieces. What we have is 2 being raised to the power of 3 and also a squared being raised to the power of 3. And so the 2 to the power of 3, well, that's 2 times 2 times 2. That is 8. The a squared being raised to the power of 3, that is where our laws of indices come in. We need to multiply those together. And so we would get a to the power of 6. In question 5, if we think of it in the same way, we just want to separate that out. So at this time, we've got 3 being squared from the power at the end, and we've also got t squared being squared. No, sorry, that's an f in there. And so 3 squared, that means 3 times by itself, that is going to be 9. F squared raised to the power of 2, well, that means we need to multiply those two powers. We'll have f to the power of 4. And finally, same idea again, I'm going to just split this up. I now have 4 being raised to the power of 0, and I've also got r to the power of 12 being raised to the power of 0. Now, what is 4 to the power of 0? Well, 4 to the power of 0 is 1. What is r to the power of 12 to the power of 0? Well, if we multiply those together, that's r to the power of 0. But what is r to the power of 0? Well, that is also 1. And so that is 1 times 1. It is 1. And the reason for that, if we take it all the way back to the original question, well, this is something to the power of 0. Anything to the power of 0 will have a final answer of 1. Now for our final set of examples, we're just going to look at some slightly more complicated versions where we need to combine together a few of our rules into the same question. And so we've been asked to simplify the following expressions: t squared times t to the power of 6 divided by t to the power of 5. Now this one all comes down to our laws about what happens in fractions. in each case, whenever we are dealing with fractions, we need to calculate the top, then calculate the bottom, and then do a final calculation after that. So the first thing here is that we've got t squared times t to the power of 6 at the top of our fraction. Now that means we're going to have to add those two powers together, t to the power of 8. But that is going to be divided by t to the power of 5. Now because that's a division, the next little step is that we need to subtract our powers. And so we're still going to have t, but this is going to be 8 take away 5, which is 3. Our final answer will be t cubed. In question 2, we've got the top and the bottom of the fraction. We need to deal with each of them separately to begin with. So a to the power of 4 times a to the power of 5, well that means we want to add the powers together, so that's a to the power of 9. And on the bottom, we've got a squared times a. Now, importantly here, if this is a, we can think of that as having its own power. It would be a power of 1. And so a squared times a, well, if I add those powers together, that is a power of 3, a cubed. When we finish it off, we just need to deal with doing a to the power of 9 divided by a cubed. Well, that would be a subtraction. So it's a to the power of 6. Question 3, we've got f to the power of 4 being divided by f squared times f to the power of 5. And so that gives us f to the power of 4. At the top, nothing has changed there, but this is f squared times f to the power of 4. So we need to add those two powers together. It will be f to the power of 7. When we deal with that, we've then got a division, so that means we've got a subtraction of the powers. 4 take away 7, well that would be negative 3. In question 4, we've got a fraction again, and so we need to deal with the first part of it, which is a power being raised to another power, which means we need to multiply, which would give us b to the power of 12 at the top. At the bottom, again, this b, we can deal with that as being a power of 1. So b to the power of 1 times b to the power of 2 is b to the power of 3. And if we were going to then do our final division, we want to subtract those powers. So it's still going to be b, but it's going to be 12 take away 3, which is 9. Question 5. In question 5, we've now got numbers. We've got letter k's, and we have letter n's, and so we need to treat each of those separately. We need to just deal with them as they occur in each section. So the first thing that I want to do is 9 divided by 3. Now there are no indices involved here, they are just numbers. So 9 divided by 3 is 3. If I go to the k section, I've got k squared divided by k. Now again, we could call that k to the power of 1. So k squared divided by k to the power of 1, well that would be 2 take away 1, k to the power of 1. In the final section, the n's, we have n to the power of 5 divided by n. Again, we could use a power of 1 there. So n to the power of 5 divided by n to the power of 1, it would be a subtraction. It would be n to the power of 4. The only thing I would do here is, because we've been asked to simplify, this little power of 1 is not as simple as this could be written. A power of 1 just means the letter itself, so it would just be k n to the power of 4. And so in our final question, we've got a b to the power of 4c squared divided by a squared bc. Now again here, we just need to deal with this one letter at a time. So we've got a divided by a squared. Now remember, that is a to the power of 1. So if I were dividing there, well, a to the power of 1 divided by a to the power of 2, I'd want to subtract the powers. I would actually have a to the negative 1. If I move to b, I've got b to the power of 4 divided by b. Now again, that's a power of 1. So b to the power of 4 divided by b to the power of 1, that would be b cubed. And then c squared divided by c, again that's a power of 1, so 2 take away 1 will be 1. We would just have c. It would be a to the power of negative 1, b cubed, c. And so to finish, we come to the exam question. It came from the Edexcel paper in June 2018, and it was on the foundation and the higher paper too. So this is one of those crossover questions, a grade 4 to 5 topic. It is on a calculator paper, but it's not really going to be that much help for us in this topic. So we've got simplifying m cubed times m to the 4. So if we do that, we know that our base is going to remain as m, but it's a multiplication. If we are multiplying with powers, we add them together, so 3 plus 4 is 7. So the first answer will be m to the power of 7. In B, we are asked to simplify brackets 5np cubed to the power of 3. So in here, we need to treat each element on its own. So first of all, I would need to do 5 cubed. I would need to do n cubed. And I would have to do p to the power of 3 cubed. And so if we work those out, we would have 5 cubed, 5 times 5 times 5, there's 125. The n cubed, well, that is n cubed. P cubed to the power of 3, well, that means we want to multiply the two indices together. That is going to be p to the power of 9. So our answer is 125 n cubed p to the power of 9. And finally, we're asked to simplify 32 q to the power of 9 r to the power of 4 divided by 4q cubed over q cubed r. And so we want to, again, just split this into little sections so that we can deal with the numbers first, then the q's, and then the r's. So 32 divided by 4. There aren't any indices involved here, so we're just doing division. 32 divided by 4 is 8. Q to the power of 9 divided by q to the power of 3. Well, that is a division with powers, so we want to subtract the powers. So that's going to be q to the power of 6. And then we have r to the power of 4 divided by r. Now we'll just remember that is a power of 1. So r to the power of 4 divided by r to the power of 1. Well, that will be r to the power of 3.